let's discuss about cardiac cycle, the pressure volume loops. Okay, so before proceeding with the entire cycle, we have to know about a few terms. Those are preload, afterload, and heart sounds, that is S1, S2. So preload is basically the amount of blood in the left ventricle before the contraction begins. Okay, so load, let's think about it as the volume of blood. So if it's preload, before pushing, right, and afterload is after pushing. Okay, so afterload basically is the amount of pressure required to push the blood out of the left ventricle so that the aortic valve opens. Okay, so layman terms mein if we think about it, preload is basically at the end of diastole, the amount of blood जो left ventricle में is remaining, that is preload. And afterload is the amount of force required to push that blood out of the ventricle. So before pushing and after pushing, वैसा याद रख सकते हैं आप. Next, let's talk about S1 and S2. S1 is when both your, if this is the heart, right atria, left atria, right ventricle, left ventricle. So यहाँ पे you have tricuspid valve, यहाँ पे you have mitral valve, and then यहाँ पे you have pulmonary valve, यहाँ पे aortic valve. So when there is closure of mitral and tricuspid, it's called S1. When these two closes, it is S2. So between S1 and S2 is systole, and between S2 to S1 is diastole. Okay, you have to know about this. Next, let's come back to the pressure volume loops. Okay, so cardiac cycle है. So cycle will be obviously an endless loop. Okay, so let's put on the arrows. It's a cycle. So we'll decide which phase to place where based on the pressure and volume levels. Okay, so this is y-axis, this is x-axis. Okay, so what are the phases of cardiac cycle? Okay, so first both your ventricles contract, right? So there's isovolumetric contraction. Then there's ejection of blood, correct? So there's ejection. Then after ejection, there will be relaxation of your ventricles, correct? So there's isovolumetric relaxation. Then after relaxation, your ventricles start filling. So this is filling phase. So filling will be rapid and reduced. Okay, so let's see. When your pressure keeps increasing, let's think of that as contraction. Okay, so contraction, and during this entire contraction phase, you can see this is the lowest pressure. If you see lowest pressure, this is the highest pressure. So from lowest pressure to highest pressure it goes, that is contraction, correct? Relaxation means it lets go of all that pressure. So this will be relaxation. From highest pressure it comes back to lowest pressure, correct? And the volume is constant here. If you see, this is the volume line, right? X-axis is the volume graph. So if you see, the volume is constant here. So isovolumetric is constant volume, and this contraction, pressure keeps increasing. Here volume is constant and pressure keeps dropping. Okay, after relaxation there's filling, correct? So this will be the filling phase. After contraction there's ejection. Okay, so first there's contraction, then there's ejection, then there's relaxation, then there's filling, what we had discussed here. Okay, so next thing is filling mein you have rapid filling, then comes reduced filling. There's rapid ejection, there's reduced ejection, correct? So we have mitral valve here, we have aortic valve here. Okay, so mitral valve opens so that your ventricles start filling, then mitral valve closes. Then aortic valve opens so that you can push this blood, then aortic valve closes. Okay, so now when this mitral valve closes, we said this is S1, correct? And when this aortic valve closes, we said it's S2, right? And between S1 and S2, we said this phase is systole, correct? And between S2 to S1, we said this phase is diastole. So if you see, this is the end of diastole, right? Here the diastole starts, then here it ends. So at this point, this is end diastolic volume, correct? And here this is, here systole ends, correct? This is the systole starting and here is the ending. So this will be your end systolic volume. Similarly, if we talk about the pressure, this is end systolic pressure because systole ends here and diastole ends here. So this will be end diastolic pressure. And the difference between these two pressures, end systolic and end diastolic, is pulse pressure. End systolic pressure minus end diastolic pressure is pulse pressure. And the difference between these two volumes is stroke volume. That is end diastolic volume minus end systolic volume. Then we have two more heart sounds, right? S3 and S4. When does that occur in this whole cycle? During the rapid phase, you have S3. During the reduced phase, you have S4. Okay. S3 is basically when there is increased filling pressure and the dilated ventricle is there. S4 is when you have a stiff ventricle. Next thing we saw is preload and afterload. So where is the preload, where is the afterload in this entire cycle? End diastolic volume is representing preload, and this point where the AV valve open is the afterload. So what we said preload is basically the amount of blood in left ventricle before pushing. So this is contraction where we start pushing. So before that, this is the end amount of volume in the ventricle, that is end diastolic volume. So hence it's representing the preload. And what did we say afterload was? It was basically the amount of pressure required to open the aortic valve and everything. So this point is afterload. Now let's discuss some conditions like AS-AR, MS-MR. Okay, what happens during this phase? Okay, so what is MS? MS is basically when your mitral valve is so thick that it is difficult to open, right? So there is a problem over here during mitral valve. So problem here बोले तो you have MS, जिसकी वजह से you have decreased filling, right? So when the filling is decreased, eventually your end diastolic volume will be decreased. So your preload will be decreased. Next we'll talk about MR. MR is basically when your mitral valve has difficulty closing, right? So this problem, closing problem, will be MR. So what happens? The blood keeps coming back into the ventricle. So the next time during the second contraction, the amount of volume in the left ventricle keeps increasing. So what happens here is end diastolic volume keeps increasing, that is preload increases, keeps increasing. Okay, next thing we'll talk about is aortic stenosis. Okay, what happens in aortic stenosis? There's difficulty opening aortic valve, so this problem here. Okay, so what happens? The pressure, it takes a lot of pressure to open. So after load keeps increasing. So this graph goes like this. So this is aortic stenosis. We have increased after load. Next, think about what happens in aortic regurgitation. This problem in closing of aortic valve, so it keeps the blood keeps coming back into the ventricle. So what happens here? There is increased volume. Preload keeps increasing. That was all about the cardiac cycle. Now they'll give you 3 scenarios, that is increased preload, increased afterload, and increased contractility. So what happens to the cycle during this 3 phases? So when your preload keeps increasing, your cycle keeps shifting here. Okay, so you will have like this, the cycle keeps shifting here. When your afterload keeps increasing, so preload is this point, correct, and diastolic volume was preload. So when your afterload keeps increasing, that is this point, your cycle keeps going upward, correct. And contractility, when your contractility keeps increasing, right, so this contraction phase keeps increasing, so the cycle is pushed in this direction. Preload this direction, afterload this direction, and your contractility comes in this direction.